Hi, this is Mark. Welcome to another discussion. And today we're going to talk about input output device systems. And to show you examples of input output devices are the following. Okay, so as you can see here, examples of input devices are keyboard, scanners, barcode reader, mouse, and others. Aside from that is an example, some of the examples of output devices are these: headphones, speakers, printers, and your monitor screen. On the other hand, there are also devices that combines the functions of input and output device. And examples of that are the following. So here in a smartphone, it incorporates input by typing in information onto the device, and output because the screen itself is showing the outputted data, and also a combination of, at the same time, also storage and processing. Another is the fax machine, where you can input data there through the keypads, and then outputted communication will be faxed onto the machine. Okay, so that's an example of combination of input and output. So the input-output subsystem of a computer provides an efficient mode of communication between the central system and the outside environment. It handles all the input-output operations of the computer system. So the input or output devices that are connected to the computer are called peripheral devices. These devices are designed to read information into or out of the memory unit upon command from the CPU and are considered to be the part of the computer system. These devices are also called peripherals. For example, the keyboards, display units, and printers are common peripheral devices. These are the three types of peripherals. Input peripherals, which allows user to input; output peripherals, which allows information to be outputted; and also input-output peripherals, which allows both input from the outside world to computer as well as output from computer to the outside world. Example, touchscreen, as you can see here on the smartphone. So next is interfaces. Okay, so interface is a shared boundary between two separate components of the computer system, which can be used to attach two or more components to the system for communication purposes. And there are two types of interfaces. The first one is the CPU interface, and the other one is the I/O interface. In the input-output interface, the peripherals connected to a computer need special communication links for interfacing with the CPU. In the computer system, there are special hardware components between the CPU and the peripherals to control or manage the input-output transfers. Now, these components are called the input-output interface units because they provide communication links between processor bus and the peripherals. Now, next is the modes of I/O data transfer. Now, data transfer between central unit and the I/O devices can be handled in generally three types of mode, which are: the first one is programmed I/O, second is interrupt initiated I/O, and direct memory access, or DMA. In the programmed I/O instructions are the result of I/O instructions written in the computer program. Now, each data item transfer is initiated by the instruction in the program. And usually, the program controls data transfer to and from the CPU and the peripheral. Now, transferring data under programmed I/O requires constant monitoring of the peripherals by the CPU. Next one is the interrupt-initiated I/O. In the programmed I/O method, the CPU stays in the program loop until the I/O unit indicates that it is ready for data transfer. Now, this is time-consuming process because it keeps the processor busy needlessly. But this program can be overcome by using interrupt-initiated I/O. In this, when the interface determines that the peripheral is ready for data transfer, it generates an interrupt. After receiving the interrupt signal, the CPU stops the task which it is processing and serves the I/O transfer and then returns back to its previous processing task. Next is the direct memory access or DMA. Now, in removing the CPU from the path and letting the peripheral device manage the memory, buses directly would improve the speed of transfer. Now, this technique is what we call as the DMA. Now, in this, the interface transfer data to and from the memory through memory bus. A DMA controller manages the transfer data between peripherals and the memory unit. In addition, many hardware systems use DMA such as disk drive controllers, graphic cards, network cards, and sound cards. It is also used for intra-chip data transfer in multi-core processors. And in DMA, the CPU would initiate the transfer, do other operations while the transfer is in progress, and receive an interrupt from the DMA controller when the transfer has been completed. Now, next is the input-output processor or IOP. This is a processor with direct memory access capability. Now, in this, the computer system is divided into a memory unit and a number of processors. Now, each IOP controls and manages the input-output tasks. The IOP is similar to the CPU except that it handles only the details of I/O processing. Now, the IOP can fetch and execute its own instructions. These IOP instructions are designed to manage I/O transfers only. Now, below is a block diagram of a computer along with the various I/O processors. Now, the memory unit occupies the central position and can communicate with each processor. Okay? The CPU processes the data required for solving the computational tasks. Now, the IOP provides a path for transfer of data between peripherals and the memory. Now, the CPU assigns the task of the initiating the I/O program. The IOP operates independent from the CPU and transfer data between peripherals and the memory. Also, here, the communication between the IOP and the devices is similar to the program control method of transfer, and the communication with the memory is similar to the direct memory access method. In large-scale computers, each processor is independent of the other processors, and any processor can initiate the operation. Now here, the CPU can act as master and the IOP as a slave processor. And the CPU assigns the task of initiating operations, but it is the IOP who executes the instructions and not the CPU. The CPU instructions provide operations to start an I/O transfer, and the IOP asks for CPU through the interrupt. The instructions are read from memory by an IOP are also called commands to distinguish them from instructions that are read by the CPU. Commands are commands are prepared by programmers and are stored in the memory. Command words make the program for IOP. CPU informs the IOP where to find the commands in the memory. So the next one is input-output channels. Now a channel is an independent hardware component that coordinate all I/O to a set of controllers. Computer systems that use I/O channel have special hardware components that handle all I/O operations. Channels use separate, independent, and low-cost processors for its functioning, which are called channel processors. Channel processors are simple but contain sufficient memory to handle all I/O tasks. When this I/O transfer is complete or an error is detected, the channel controller communicates with the CPU using an interrupt and informs CPU about the error or the task of completion. Now, each channel supports one or more controllers or devices. Channel programs contain lists of commands to the channel itself and for various connected controllers or devices. Now, the following are different categories of I/O channels. The first one is multiplexer. The multiplexer channel can be connected to a number of slow and medium speed devices. It is capable of operating number of I/O devices simultaneously. Next one is the selector. This channel can handle only one I/O operation at a time and is used to control one high-speed device at a time. And lastly is the block multiplexer. It combines the features of both multiplexer and selector channels. The CPU directly can communicate with the channels through control lines. The following diagram shows the word format for channel operation. As you can see here on the diagram, the computer system may have number of channels and each is assigned an address. Each channel may be connected to several devices and each device is assigned an address. So this ends our discussion on input-output device. Thanks so much for your time. Have a nice day. Bye.